We're starting with ratios, rates, and proportions. And so we're going to cover a few of those key concepts like factors, reducing fractions, doing some rounding in this first little section here. So in terms of factors, recall that a factor is an integer, so a number that is without a decimal, that divides evenly, meaning no decimals, no remainder, into another number. So when we're doing our division, we're not using any decimals. Our answer shouldn't have decimals, shouldn't have a remainder portion. So in the case of 24, we're asking what are the factors of 24? Well, this is a list of numbers that divide into 24. Now, any number can be divided by 1. As well, 24 can be divided by 2. You get 12. 24 can be divided by 3, which would give you 8. 24 could be divided by 4, which would give you 6. And now that's also meaning that 6, 8, and 12 would also be factors, because 24 divided by 6 is 4, 24 divided by 8 is 3, 24 divided by 12 is 2, and finally 24 divided by 1 is 24, so 24 divided by 24 is 1. So 1 in itself will always be factors that we can use when we're working with the factors of a number as well, and those pairs along the way. And they'll always be coming in pairs. Factors come in pairs. So a factor pair is a set of two integers that multiply to another integer. So 1 and 24 are factors of 24. 1 times 24 is a factor pair. So what are the factor pairs of 24? Well, we have 1 times 24, which equals 24. We have 2 times 12, which equals 24. We have 3 times 8, which equals 24. And we have 4 times 6, which equals 24. So those are all the factor pairs. And they can be written in opposite order as well. You could have 12 times 2 equals 24. That would be the same as 2 times 12. The order doesn't matter when we're multiplying. Now, along with just general factors of a number, there's also the greatest common factor, which we use when we're looking at two separate numbers. So the factors that we've looked at here are just the factors of a specific number, one number. When we're working with multiple numbers, we are generally going to look for the greatest common factor. So the greatest common factor is the largest factor that's the same between two different numbers. So in the case of 8 here, we want to know what the greatest common factor of 8 and 20 is. 8 has factors 1, 2, 4, and 8. And 20 has the factors 1, 2, 4, 5, and 10. So between 8 and 20, the greatest common factor is the 4. They both have a factor of 4, and it's the largest factor that matches. They also have factors of 1 and 2, but 4 is the largest of the factors between 8 and 20. Now, moving on, if we look at reducing fractions, when we're working with fractions, we're just working with a division type of question. So really, fractions are division. I know people get uncomfortable with fractions. They don't like fractions for whatever reasons, but the division sign is a fraction. That's where that representation comes from. So when we're dividing, or when we're working with fractions, we're working with division type of questions, and it's just simplifying division because sometimes it's easier to work with in decimals. And actually, in many cases, it's preferable to work with fractions than decimals, and we'll be using them throughout the year when we're looking at things like rates and some of our graphing. So in the case of our example here, we just want to divide out some numbers. 24 over 3 is a fraction. But 24 over 3 is the same as 24 divided by 3. and that equals 8. 66 over 6 is the same as 66 divided by 6, and that equals 11. So those fractions are actually representations of numbers, of integers, sorry. So useful to know that when we're working with fractions, and also just this bar here, this division bar is used when we get into some algebra sometimes. Not so much this year, but more when you get into the later grades. Now, when we're talking about specifically reducing fractions, we're still working with the concept of division, but in this case, we're going to combine our greatest common factor concept with the fraction and division. So we need to find a greatest common factor between the numbers. Now, if you need to, you can write out the greatest common factor, or sorry, all the common factors until you to find the greatest common factor, or if you know it already, you can just divide it out. In the case of 5 and 25, 5 has common factors of 1 and 5, and 25 has 1, 5, and 25. So the greatest common factor is 5. So we're going to divide both the top and the bottom by 5 to reduce this. 5 divided by 5 is 1. 25 divided by 5 is 5. That reduced down to 1/5. Now in the next one, 8 and 20, I'm going to show you how you might do it if you don't know the greatest common factor, and this is especially useful when you have some larger numbers and you don't want to write out all the factors of, say, like a number like 753, maybe 752. But what you can do is look at the numbers and start dividing out factors that you do know. 8 and 20 are both even numbers. So we know both of these divide by 2. So I can try dividing each of these by 2. And when I do, I'm going to get 4 and 10. Now looking at 4 and 10, I know those aren't as small as they can be because they're both even numbers. So I can divide both 4 and 10 by 2 as well. And 4 divided by 2 is 2. 10 divided by 2 is 5. So I get 2/5. So that there is another way to factor these, or reduce these fractions down. If you don't know all the factors, you can just start finding a factor that is common between the two and divide it out. The greatest common factor in this case would have been 4. And if you notice, 2 times 2 is 4. If we would have divided both of these by 4, we would have got right to the 2/5. Both of these methods work. Whichever way is most convenient for you to find the missing factor is the best. When we worked with reduced fractions, we are actually working with what are called an equivalent fraction, meaning that these fractions are equal to each other. They're not the same numbers, but they're the same amount or proportion. For example, if we have a little circle here and we cut it in half and we shade in a half, so this could represent 1/2 right here. But also, if I take that circle and then I cut it in half again into quarters, 2/4 is the same amount as 1/2. So equivalent fractions just mean that they're the same amount, but broken up into smaller or larger portions. So in the case of reduced fractions, like the one in part B, these are all 3 equivalent fractions. And so we can find these fractions by dividing, like we did above, or we could also multiply to find them. So in this example here, we want to find larger and smaller equivalent fractions. So from 4 over 18, we could divide both of those by 2. They're both even numbers, so let's divide them by 2. We get 2 over 9. And then to go up, we just multiply them by any number. We could multiply them by 2. We could multiply them by 3. We can multiply them by 7. Let's keep it simple and we'll multiply by 2. 4 times 2 is 8. 18 times 2 is 36. And there we have 3 equivalent fractions, one smaller, one larger than the base. In the case of 6 over 4, we can use those same ideas. 6 and 4, the only number we can divide those both by is 2. And so we divide both those by 2, we'll get 3 over 2. And then let's multiply them by 5 this time. 6 times 5 is 30. 4 times 5 is 20. So it doesn't matter what number we multiply them by, so long as we multiply them by the same number. And here we have equivalent fractions. Now notice, 3 over 2, 30 over 20, that's a factor of 10. Well, there's a 2 here, a difference of 2 here, a difference of 5 here. So 2 times 5 is 10, which makes that big jump all the way over. So just something to note. And in the last bit here, what we want to look at is some rounding. And so if we're rounding numbers, we have here a little table with the number 123.456. Note how I said it's 0.456. In most cases, we don't list the decimal part as a number. It's not 123.456 is not how we read that. We do read in terms of dollar values, the dollars and cents portion. We read the cents portion as a number, but that's because we're actually treating it as two separate things. We're actually looking at them as two separate numbers. In this case here, though, and in most cases, it's normally stated as a list of the numbers after the decimal. Just like we say something like pi. Pi is not 3.14, it's 3.14. And the reason why, again, is because of the way we read numbers properly. So looking at our columns here, that I've broken it up into, we have our ones column, our tens, and our hundreds. And then just to make it a little more complex, because the S and the TH at the end can kind of slur together a bit, we go backwards now. We don't have a oneths column. We start with the tenths. This is 4 out of 10. Then 4, 5 out of 100, and 4, 5, 6 out of 1,000. So we have tenths, hundreds, and thousandths. And again, saying it can sometimes be confusing, but it's pretty easy to read when we get down to the questions. So when we are rounding, recall that we look to the right of the place value. So if we were rounding to the nearest tenth, we would look to the right of that here at the 5. If the number is greater than or equal to 5, we round up. Otherwise, we round down. So some examples here. If we have 74683, 74,683.1 rounded to the nearest 100. Well, the 100 column is right here at the 8. We look at the 3. That means we round down. So we round down to 7,406 or 74,680. So we round down to the sorry, that was the 10th. My mistake. Let's fix that. The nearest 100 would be the 6, and we look at the 8. That's the 100 column. And so the 6, we look at the 8, which is greater than 5. We round up. And so that rounds up to 7. And we could put the 0.0 in as well, but the 0.0 is not needed now. So 74,700. So that's rounded to the nearest 100. Now, in the next one, we want to round to the nearest 100th. So 74.6831, round to the nearest 100th. The nearest 100th is here at the 8. And so we'll look at the 3, the number before it, and that will round down. So we'll have 74.68. and we can just drop the numbers at the end. All right, so the next thing and last bit here for this lesson is when you're rounding up or down, you can use more than a single digit rounding. So here we just rounded to the nearest digit, here to the nearest digit, but we can jump more digits if we need to. We can jump and round to the nearest 5 cents. So if you're at the store and buying something with cash and it comes out to $10.68, they won't charge you $10.68. They'll charge you $10 and the nearest 5 cents here. This rounds up. So the nearest 5 cents, the breaking point is 7.5 at the upper end and 2.5 at the lower end. So 5 is in between there, otherwise it goes up to the next 10, or otherwise it goes down to the 0. So in this case, 68 above the 7.5. This is above 7.5 here at the 8. So this is going to round up to 10.70. So they're going to charge you $10.70. If something costs $16.91, well, the 1 is below the 2.5, so that's going to round down to $16.90. So you can round by the nearest 5, 10, 15, 25, whatever setup is required for the situation. So we got some factoring, we got some rounding, we got some fractions, and you can try out some of those practice problems to see how well you made out with this.